Hello people, welcome back to my channel and hope you are enjoying the Python series. I have uploaded two videos and this is the next video. Today we'll be covering about what are operators in Python. If you are familiar with the other programming languages like C, C++ or Java, you might have already uh, what all are the basic operators which you use in that. But in Python, there are some more extra features that this operators can do. That is, they have even more power on the string as well as the numerical value to operate on. So where it was limited in C, C++, or in Java. So today we'll be seeing what are operators in Python. There are uh, these many operators, like you have arithmetic operator, relational operator, logical operator, bitwise, assignment, identity, and membership. So from this, the last two operators, that is the identity and membership, might be new to you, or these are exclusive to Python. And the important thing to remember is if you have a C background, that is C programming background, then you might have used the increment, that is the pre-increment, post-increment, or the ternary operator even with Java. Or in C, you have infix, prefix, and postfix notations or operations. So Python has no such kind of thing in this. Python has no increment, no decrement, and ternary operators. So this is the point that you should keep in mind. We begin this session with first the number systems. So number systems basically are of three types. The binary number system, which is of base 2. Then you have the octal binary system, that is of base 8. And then you have hexadecimal, that is of base 16. If you know the computer organization stuffs, then you might well know like how you convert these things. So in Python, you have built-in methods from the math library, so you can directly use this. So we'll directly jump into the examples of how we can use this. So we'll write some code here. So first of all, let's take some variable. So let's say we have a variable as we'll assign it as 10. Okay. Now this is of integer data type. Now what we do is we convert this to binary. So if I write bin binary, so you can see the pop-up when I hover my cursor on this returns a binary representation of an integer. So we will pass the value of variable to binary, and if I print the value of this y, so what I obtain is 0b1010. So this is the binary representation of the variable 10. That is the value, decimal value 10. If I have something like 12, then it will give the respective binary conversion of that. And next what we have is the octal. So octal is of to the base 8. So octal is to the base 8. It will give you like this kind of representation. This is 0014. And if you want to try with some other number, say like 116, it will give you the required conversion. Next what we have is we have the hexadecimal, which is of base 16. So if you do this, then you have this conversion to base 16 for hexadecimal. Now if you say if you convert this to binary, we'll get some other notation 0b 0c 0x like this. And so if you don't want this kind of like, if you say like I don't want this 0b, from the starting two positions, I don't want 0b, just I want triple one zero one double zero, which you usually do by hand calculations. So you don't write 0b there just for this representation. In computer systems, you have this 0b. So can I perform that operation like I don't want this 0b? So well, it is possible in Python. It is done with the help of something called as slicing operator, so that we will later see when we do arrays and all those operations, multi-dimensional structures. So in that you mainly use this slicing operator. So how slicing is done? Now we want to do the slicing on the result, which is the converted value. So our converted value is in y, so we will apply the slicing over y. So how do we do that? So before this y, what we do is we just open a bracket like this, that is a square bracket, and inside this, since I don't want the first two, that is I don't want this 0 as well as b. So one important thing in Python you need to remember is that the indexing always starts from 1, as opposed to some other programming languages where it starts from 0, or in array also it is also starts from like 0. Like if you have an array A, then it will be A of 0 or A of 1, it goes so on. But in Python, the indexing or the starting position of any element or any object starts from 1. So what we basically write here is we have 2 and we write 2 colon like this. So remember, like these are two fields that we are keeping empty. So this is like a step operator, and this is at the last. So whatever, if you don't want to print values on the backside, you use this. So later we'll discuss on this. So now from this slicing, what we are doing is we are skipping two values from the beginning. So ideally it should result like triple one zero one double zero. So let's check whether it is giving the output. Yeah, it's perfectly giving that. And say like if we want to do in octal, yes, it works. And in hexadecimal, yes, it perfectly works. So this is all about the hexadecimal, that is uh, the number systems which are there basically in Python. So these are the various operations which you can do. Next, what we do is we have the first type of the operator that we discuss here, that is the arithmetic operator. So arithmetic operator is like you have addition, subtraction, multiplication, division, and modulus, and these are the basic arithmetic operators which you apply on real numbers. But here Python has more to offer you in terms of strings as well. So let's see. So basically this is the like easiest thing that you can do, like 3 plus 5, if you do it, it will give you 8. Or with minus, you have minus 2. If you have multiplication, then it will give you the desired result. Now what we'll do is we'll see the difference between this symbol and we have something like this. So these are two different things that we'll see in Python. So there is some difference, a slight difference in these two. So if I write this, that is, let me clear this output first of all. Okay, so we have 10 divided by 2. So basically when you do the arithmetic or when you do the math from your like basic school, it will be 5. But just to remind you, this forward slash, this is the division operator, and this returns always a floating value, that is with decimal. So instead of 5, it will give you 5.0. It is taking some time. Yeah, so it is 5.0. So the result of this forward slash, the division operator, is always a floating point, that is a decimal number with zero point 0. Now what if I don't want this zero point 0, just a real valued number, just only 5? Put the forward slash again and you get the result as 5. So this is the basic difference of uh, what the arithmetic operators has. And you can also do some certain kind of calculations, like if you have a number like 2, and if you are doing to compute this, so it will be minus 2 into minus 2, that will be 4, then again minus 2, so that will be minus 8. So this you can also do with the help of power function, which is there in the math library. So it is equivalent to xy, which we did previously with two arguments. So what I wrote before, I have minus 2, that is this to the power of 3, it will return the same result. So now I also mentioned like Python has some more to offer, or it has something more to offer in terms of arithmetic operations to string as well. So if you see C++, Java, in these programming languages, these operators, arithmetic operators, were only limited to these numbers or real valued numbers, numeric values, but it was not applicable to the string data types or the string types. So what we now do is we'll create one variable, that is x. So in this, what I do is I write a name, my name, and in y, what I do is I create array. So now I make use of x plus y, and then I should store this in z variable, and I will basically print this value of z. Okay, so now ideally what it should be giving the output Ranji Raj. Is it giving? Yes. There should be some space. Either you can put it after here, that is a white space, or you can put before this. So it will give you like this. So the bottom line is, if you use this arithmetic operator between two strings, it will concatenate them. And what if what if I do instead of this? Is it possible? No. It gives you a type error, because it can't multiply sequence by non-integer type of string. So instead of this, what I do is, instead of this I write 3. So it will give you this string 3 times. So these are the common things we should keep in mind. So these types of operations are also possible with strings, and it's not limited just to the numerical values. So this is the foremost thing you should remember when you deal with arithmetic operators in Python. So that's why we are doing this kind of activity, or just a brush up of this arithmetic operators. So this was the story of arithmetic operators. So the bottom line is, it not only works on numerical values but also works on string values. Now, what we move is to the relational operators. So, relational operators are nothing but you have this comparisons like greater than or less than equal to, greater than or equal to equal to. That is equality operator. So, this you already know from your math class. You might have used this to compare two numbers, which is smaller, which is greater, and so on. So, it will return you some true or false kind of values. Say we have 5 greater than 3, it will give you true, or like this, it is false. Or you have different kinds of things, or you can use like this to check these two numbers. False, obviously false. So these are to the numbers, but the cherry on the cake is you can use this with strings too. So how do they work? So again, what I do is I create two uh, strings ABC, and say I have DEF. Now what I do is I check, like I store this in A, is it equal to B, and I will print this, print C. It is false because you can obviously make out, like first string has ABC and second string has DEF. Obviously it's not same. But what if, like we use this operator comparison in between these two strings? Does it work? Yes, it works, and it gives you false. Now why the result is false? Because this basically checks in the dictionary order or the alphabetical order. So ABC is the first three alphabets, and then comes DEF. So DEF has higher precedence, or like it comes after ABC, so that's why it is false. So if you check like this, then it will be true. So this was the extra part which is there in relational operators for strings in Python. Next, yeah, and one more thing that I just want to add to this is, like we learned one more data type, that is complex data type. So say we have some like 8 plus 6j, and we have 5 plus, or let's take that same value, 8 plus 6j, and let us see does this work or not. Instead what we'll do is we'll do the equality. It should be equal, right? Yeah, so it works on this kind of complex numbers as well. So now let us move on to the next, that is we have logical operators. So you know the logical operators, like in C and other programming languages, you have this kind of operators like and, or sorry, you have this for or, this for not. But in Python 3 the story is different. They just have made the simplification to all these kind of stuffs like that, because the next portion is like bitwise operator. So here you just have to consider only one ampersand or one pipe operator. So that becomes a like confusing thing, which is logical or bitwise. So that remains like a confusion if you already have done C or Java or C++. But in Python, this is different. So they have made the thing simple. So instead of this double and, for the and, you just have this word and for or you just write or, and for not you just write not. So it is as simple as that. And so the result is always the same, like relational operator, it will be either true or false. And just one more thing is, like if we have some non-zero value, so if you have some non-zero value, means it is not zero, like 5, 4, 3, 1, something like that, other than 0, that will always be considered as true. And if you have a zero value, so it will be always false. So this is the rule that you have to keep in mind. So whenever in digital signals or signaling systems, in electronics, like whenever a bit value is 1, that means it is on, and if it is 0, that means it is false. So similar logic you have to keep in this. So non-zero value, every non-zero value it is true, and every zero value it is false. So let us check this, we'll do one small routine here. So what we have is, let us take value 5, and then we have 4. So first of all, what we have learned just before, like for every non-zero value it considers as true. So you can see 5 and 4 both are non-zeros, so the result will be true, that is true and true, it should be true, that is 1 and 1, it should be 1. So but if you so ideally if you think over this, it should give you true value, but instead it gives you 4. Now why this happens, or what is the logic behind this? So say like 5 is true value, but means it is non-zero, so it will be true. So if the first value is true, then it will give the output of the next immediate next value, so that will be the output, so it will not check the next value whichever it is. So instead, if it is like, if it was 0 and 4, now 0 means false, false and 4, so it should be 0. So it will give you whatever value it is, like the like false part value or the true part value, it will give you that non-zero element or the zero element, it will return. So that is a basic difference here. And if you have like this, it will again return 0. So it is as simple as that. Like if you have 1 and 1, it will give 1, then in that case only it will be 1, that is true and true, it will be true, in all other case it will be false, so 0 represents false. So that is the basic difference. And one more thing is like this does not works with strings. So say like we have two variables, I think we have to create that. So let's say like this is a, and say we have another one, that is we have b, and okay, so it should be y. And what we do is we perform, that is x and y. Yeah, so it works. Now next what we have is we have something called as the bitwise operator. So bitwise operator is somewhat similar. No, it is not similar, it works on bits, each and individual bits that you have. So say for example, like if you have something like 5, and if you put this, now here actually this ampersand comes into picture. So in logical operators, you have to write the word a and d, and, or for or you have to write or. So now here what happens is like if I take two decimal values like 5 and 6, it will give you the result like this. Now this conversion is like you can write 5 in decimal number system, it is 101, and for 4 it is 110. And so if you perform the AND operation, you'll get the result as 4. And if you have to perform OR like this, if you use the piping operator, it will give you 7. So you can try this out by your hand calculations, you can check this result. And then similar is the case with the XOR. So XOR here is represented by this cap, it is called as caret, the symbol is called as caret symbol, and so it will give you like this. So it is the XOR operation like you do in your truth table, so it is simple as that. And then you have something called as the complement, that is represented by this, that is tilde. So this is a tilde symbol, and if you just put over 5, it will give you this so it is basically the ones complement, and then you have the twos complement, things like that. So it will just flip the bits with a negative sign. So similar thing is there. So for 7 you will have -8, and for 4 you will have -5, like this. So this was the discussion for bitwise operators. Now let's move on to assignment operators. So uh, for assignment operators we have, yeah, so for assignment operator we have to keep in mind like two things. So there is one more to assignment operator, that is called as the compound assignment operator, which checks for the precedence of the operators. For the arithmetic operators, we'll see that with the help of an example. So first of all, if we have, or if I have a statement like we have been writing from the beginning, like we have, if we write something like this, then what does this mean? Whatever value is there, or whatever portion is there on the right hand side, it will be assigned to the left hand side. So x contains value 3. So in the memory block, or the memory region or memory area, you will have a at some address, particular address. We know the address of this particular x, that it will be like with the help of the id operator, or id method. With that you get the address of this x, and inside that x you will have the variable 3. Now if you do like this, y is equal to 4, and now if you perform like x is equal to y, so this double equal to, which you can see, this is different from this. So this one single equal to sign or equal sign is called as the assignment, and if you encounter a two equal to sign one after the other, that is called as the equals, or does the value of x match with the value of y. So here it is false, because they both contain different values. So this is the difference that you have to keep in mind, like one is the assignment and the other one is equals, or check for the content, means it checks the content and not the memory address. So that we have done in the previous video. So if you want to just revise that, make sure like you can check that. So now we shall discuss something about the compound assignment operator, more to this. So compound assignment operator is something like, if I write x is equal to or x plus is equal to 3, so what does this mean? Or so like say like we have x is equal to 3, and I write x plus is equal to 3, so what it will give you? Okay, I have to write some code here. Okay, so this is basically x is equal to x plus 3, and then I will print x, so it will be 6. So the prerequisite to this compound operator is that you must already have a value which should be defined prior to using this. Means first it will take the value of x as 3, then with the help of this compound operator. Now this goes with all the arithmetic operators that you have learned before in this session. So first x takes a value of 3, then it will be 3 plus 3. So x is equal to x plus 3. X already has 3, 3 plus 3, that is 6. We get the value as 6. So this goes with all the other operators like subtraction, multiplication, division, and double, slash, modulus, etc. So now we shall do with what is called as the compound operators. So uh, what we do is we take one value, x is 10. So value of 10 is assigned to variable x, and then what we have is x star is equal to 4 plus 15, like this. So now what should be the result for this? So we know like this is a mm, compound operator. Like in this particular line we have two operators. uh, you can see three operators, but this part is considered to be one. So it is x is equal to x into 4, so it is read like that. So this is considered as one, and this is considered as second. So we have two operators in this. Now in this how this basically works is like, first you check the precedence. So precedence of arithmetic operator is higher than that of multiplication operator. So when you perform this, you get this. So it will be 15 plus 4, that is 19, and then you multiply it with 10. and so you get 190. So this is how it works. Next, let's change this particular statement somewhat to like this. So if I have, say, x is equal to x multiplied by, you have 4 plus 15, like this. Now what should be the output? So here you get some different kind of value like this. So how this basically works? So now here, you can see, like, let us split this first like this with help of spacing so that it becomes more and more clear. So whatever, so this particular value to the right hand side will be assigned to x, and that we get as 55. Now how this basically works? Now here we can see, like, you have one and two operators. Similarly, that was the case previously, but there it was star is equal to. So that was the assignment operator, compound assignment operator. Now here how it basically works is the precedence of multiplication is higher, so that will be performed first. So first it will do 10 multiplied by 4, you get 40, and then with that you add 1 5 15, and so you get the value as 55. So this is the just difference. So this is the precedence of how the different operators, compound operators as well as arithmetic operators. So arithmetic operator will always be higher in precedence in comparison to the compound operator. So that is the bottom line. Next, we have to deal with two more operators. That is, we have the identity operator. So we already saw, like, we have this equality, x is equal to y, this kind of stuff. And now here what we do is, this basically checks the value. So I said, like, this basically checks the value. So if you have x is equal to 5, say, and y is equal to 10, and if we check whether is x is equal to y, whether the content in both these variables equals to the same or not, so it will give you false. Obviously the value in both these variables are different, so it should give you false. Now the identity operator is characterized by this keyword is. So you can see from the keyword list, for that we have a separate program, a small 2-line program, to get the all the keywords which are there in Python. So you can do that to check whether is a keyword or not. Obviously it should be, otherwise it won't come in blue. So now how do you use this identity operator? Means it will check the reference, means the memory reference, whether it is referring to the same memory location in the RAM, it will check for that. So now what we do is, we just check, like, it is false. And if we do, like, okay, mm, yes, it is true because the values are same. So this is just the identity operator, that is, it will check for the value in both of these variables in x and y. So just for to introduce this is, we have this identity operator just to check. So the bottom line is, to take away from this discussion is, like, if you use double equal to this one or is, both are same, so you can use both of this just to check the value. Next what we have is, we have the final discussion over the operators for today's session, that we have the membership operator. So membership operators are basically characterized by two keywords, that is, we have in, and then you have not in. So these two are different. You have in and not in. So From the name itself, you will like, you can guess like, uh, from where does it check. So it checks the contents. Basically, the things or the items should be iterable. So you need to have some kind of a data structure, something like that, so it becomes iterable. Okay, so if we have say like x is equal to like 1001 like this, and if we do like whether 1 in x, is this possible? No, this is not possible. It throws a type error, and if you see like argument of type int is not iterable. So you have to focus on this, that is iterable. It should be iterable. So now this entire thing is a number, so you can't iterate over it. So that is a basic problem here. So it should be basically iterable in this. So for that, what you do? So if you have something like this, this also is a error. So in string requires string as the left operand and not int. So this always works on string. So now what we do is, we'll just resolve this. We'll understand on where does this work. So if we have say a name like Henry, and if we check like e in x, okay, mm, we have, okay, we have to check for this string. Yes, so you have to check for the string in this particular string. So this is a substring from this main string, so it basically checks that. So similarly, this is case sensitive, it is false, you don't get in this, uh, and like if you have this, and if you just use the not in stuff, so that is the reverse, that becomes true. So, well, that is all about the discussion regarding the different operators, and hope you got like something more about the operators and the precedence and what all are the capabilities of these operators, as opposed to in other programming languages. In Python has a wide variety, like to extend to string data types as well. So you can get to know what is the power of Python in machine learning to do over these kind of things. So that's why it is the most widely used. I keep on saying this because you get motivation to learn Python programming. And so that was all regarding the today's session. So hope you guys enjoyed this video. If you want to get educated watching this video, please do like, share, comment, and if you are new to this channel, please consider subscribing. Thank you very much for watching this video.